So this is a small video to invite you to play with our QuantImage v2 platform to try to build the best model predicting MGMT status from this Brats 2021 dataset. So let me take you to the platform to explain the different functionalities and then how you can build your own model with your own account using the platform, the web-based platform under this address here. So you can access the QuantImage platform via this link with any browser, and then you can here look at your dashboard, and here you should see only your album Brats MGMT 2021, and here you can look at the different studies, then start to extract features. You can also go to the corresponding KEOPS album, looking at all the patients if you like to. You can also browse the specific images with the 4 MR sequences that we are considering. Also the region of interest here that was generated by deep bratumia on those, and you can verify everything is correct for further feature extraction. Then when you're convinced that's the case, you can go back to QuantImage and then extract features. So here we have predefined presets for here the particular case of MR, these 4 sequences. You can look at the different pre-processing and configurations of those. If you want, you can also try with your own configuration via a YAML file like that. Here you can see, for instance, we are standardizing the images, and then you select the region of interest and you can click extract features. Here it's already done, so you can directly click to explore features, and you're entering this feature explorer, which means it's just the beginning of the clinical study here, where you have a summary of all the features that were extracted. You can also download them at this point if you want to use them in another software. You can look at this feature table. It's not very useful, but just check everything's correct. And here you can upload the outcomes. So obviously you need outcomes for predicting here in particular the MGMT status. So this could be, for instance, a CSV file, because here we have more than 500 patients. Right away, you could jump to a machine learning model, for instance, lasso regression with some standardization of the features, and look at the performance using this entire set of features. So it's about 800 features, because we have 4 image frequencies, 3 region of interest, and here you can see, for instance, this is a performance of 56 in terms of AUC. You could try another algorithm at this point, like random forest, and look at compare the performance here in terms of AUC, but also in terms of other performance metrics if you like to. Now, what you can do is to go back to the set of features and then start to filter out with what you're interested based on your hypothesis. So let's see maybe that MR flare is containing the signal for MGMT status. Then you can also remove some of the region of interest. And for instance, here you could look at this enhancing tumor. We can see with these heat maps here we have features as lines, patients as columns, and we have here a clear thing with a clear pattern with the intensity features, which is a bit surprising, and so maybe we need to investigate into that. Here you can also rank by F value, so this is another statistic to look at which features are most correlated with the outcome here. You can also drop correlated features, because you can see in this heat map there are lots of correlated features. And then when you're happy with this set, maybe you can also start to filter out some specific groups of features like intensity, texture, etc. But when you're happy, you can create your own sub-collections and then start to build a machine learning model based on that. So we can call it MR flare, enhancing, and decorrelated, because you removed correlated features. And this is your new collection. So here I already have lots of them, but this is the new one. And you can do with go to model training and then try again with these new sub collections and see if this improves your model. So this is not the case, but you can always go back and investigate which sets of features, also based on your hypothesis, you can add here.